Hi everyone, how are you guys? Today we'll go back to Calculus 1. I have a request from some of the students to review with them the definition of the derivative. And today what I'm going to do, I'm going to show you how to find the first derivative using the definition. Then I will explain what the meaning of the derivative. For calculus students, if you remember in early ages, in pre-algebra, we start with the defining something we call a slope. Slope, rise over run. Rise over run, that's all. Which is, you find you have 2 points. What you do with these 2 points, you find the difference in the y's, the difference in the x, you divide the difference in y over the different x, and you find the slope. And you learn that you have a negative slope, positive slope, and you have a slope equal to 0 and a slope equal to undefined. For horizontal lines, slope equals 0. Then after that you develop your concepts till we reach to calculus. Calculus, built on the definition of the derivative, is the derivative mean is the slope at a specific point. You find the derivative in general, but if you want to evaluate the derivative at any point, the meaning of the derivative at that point is the slope of the tangent line at that point. Look what I did. If you have function here, before I start, if you have this our information, if you have any question, you can text me or send me an email. And as I said, what I'm going to do today, calculus 1, derivative definition and concept, find the derivative using the definition. Don't forget to like and subscribe, please. And we have SAT classes, SAT registration class start tomorrow. You can register. And we have calculus 2 classes. That's what we have. Now, let us go leave this and go to this. Look here. This graph of any function, it doesn't matter. Look here. If you take this point 1 and 2, this point 1 and 2, 1 and 2, 1 for x, he counts 1.5, look here, you see guys, 1 and 2, this point. Okay. The slope, you can easily find the slope, right? The slope of this line is rise, which is 2, and x is 1, my slope is equal 2 over 1, which is 2. Now that before. Now this my function, the blue one, the derivative of the function, if we define the derivative like f prime of the function, I'm going to show you how to find it. But the slope now, m equal f prime of the function at x equal 1. Good. And that equal to 2, directly from the graph. If the teacher asks you, you see, you find the slope of the tangent line. This line, you see the black line, is a tangent line. Is a tangent line at the point which is touch that curve, the blue curve at one point, which is 1. Touch the blue curve at one point, which is 1. Look to the other guy here. Look to the other guy here, which is at what this point? 0 and 3. This is a horizontal line. I know from the previous knowledge that any previous line has slope equal to 0. That means f prime of what? 0, equals 0. The slope of the tangent line for the curve at the point 0, at point x equals 0 is 0. Where else we can find it like this? You done with this? Let me read this guy to make the board clear. Look here. Look these. Look, I'm gonna try to show you. Now we know this. Now you see this point also. Let me just see what this point. Look at this point here. Okay, let me just get rid of this. Okay, and see what this point. It's about negative 0.866, right? I'm gonna graph line. Y equal what? Negative 0.86, negative 0.8666. Let me get my negative 0.866. No, y equal 0.1875. 1.875. 1.875, right? 1.875. You see? You see this line here? What the value of x here? What? Then we have, look at the value of x again, negative 0.86. That means f prime of the function at this value equals 0. F prime. Because the slope of this line is what? Then I can say f prime of negative 0.866 equals 0. And the test, and if you see what the value of the derivative at this point, since the tangent is horizontal, that means what? Since the tangent is horizontal at the value of x equal negative 0.866, right? Then my function, the derivative is 0. The same thing here. The same thing for this one, which is 0.866. 0.866. This is the definition of the derivative. This is the concept. That's what I want to explain for you. The derivative, in general, is built to find the slope of the function at a specific point. We call the line that passes that point a tangent line. What do we call it? Tangent line for the curve. We have a lot of tangent lines. You can graph tangent line here. You can graph tangent line here, here, here. At any point you can find the slope easily. Or since you have the derivative, you can find the slope easily. Okay. Let me go and show you what the definition of the derivative. Let me show you the definition of the derivative. Okay. Let me go. Okay, let me open my board. Let me make sure that everything is okay. Okay, guys. Bear with me 1 second. I need to fix it for you very well to be able to see everything. Now, this is my board. And I will open this guy. And here, look here. Let me just minimize it. Okay. Calculus, our class, derivative, definition, and concept. We said the concept is the slope. The derivative means the slope of the line, the slope of the tangent line, again, the slope of the tangent line at any given point we have. Good? Given that. Now, always we have to, before we have an easy way to find the derivative, what I'm going to show you in different classes, a simple and easy way to find the derivative. And you can find the derivative in a very simple way, just by looking to the function with some practice. But for now I will show you the definition. This is the definition of the derivative. You see that? F prime of x equal fx plus h minus f of x over h, the limit as it goes to 0. Now, I'm positive your teacher discussed the limit, and I'm going to post some videos about the limits later on next week or the week after. But for now, let us focus on the derivative. The limit of this function, right? The limit of f of x plus h. What I mean by f of x plus h? For any function I have, the meaning of f of x plus h, I have to take x plus h, replace it by any x I have in my function, like this x and this x. You will see now when I start solving the problem. Now what we have to do, using the definition of the derivative to find f prime of x, we have another name for f prime of x. Sometimes he will ask you f of prime of x, dy by dx, the same thing, the same exact thing. dy, sometimes they call it y prime, sometimes copy or y prime, or y, or if you want, instead of x, we're gonna put y prime. Sometimes y prime of x, or just y prime, or just what? Y prime. Then could be f prime of x, could be dy by dx, or what? Y prime. Any one is good. Just name. It just what? Name. Now let us see how we apply this formula to find the derivative for these three functions, a, b, and c. Usually in your test, you're gonna have one of these formats, either quadratic function, square root function, or rational function. Rational function here, this rational function, this square root function, this is quadratic or second degree function, or polynomial. Cube, it's three. And it's hard for the teacher in the test to give you cube, but I will discuss it in one class because it's going to take time from me to do it. Let me see. Look, I made a nice table for you just to understand. Let us take the first function and put it here. And let us find the derivative of this function. Okay? Okay. What I have to do here. Look what I'm going to do here. Leave this alone here. I'm going to back to this. I'm going to find now what? This guy. I'm going to find f of x plus h. You make it smaller. Equal. This is my function. I'm going to copy this function. I'm going to put it here. Control. Put it here. You see the x here? The x, I don't need it. I'm going to replace it by what? X plus h. Copy this. Take this out. The x. Change it. X. Oh, nice. And we have another x here. Oh, good job. Good. Then now what I need, guys, I need to expand x plus h squared. X plus h squared. X plus h squared. Let me just make sure everything. I need you to like your name always. I'm gonna expand it for you for the first time. X plus h squared. At the end, I need to memorize it. This x plus h and x plus h, which is FOIL x squared plus xh plus xh plus h squared, which is x squared plus 2xh plus h squared, which is very well known. This x plus h squared. Then let us back to our board and take this value and apply it where into my formula. Then this guy will be 2. I'm going to take only this. And then you see this one here, all this will be x squared. Leave the 2 alone. I'm going to write it down. 2. Oh, we say x squared, right? We said x squared and I'm gonna take this out. I'm gonna do 12. Hold on. I'm gonna take all this out. X squared plus 2xh plus h squared plus h squared. This h and this is square. Close your parentheses. Close it. Now x is blue. And h is red. Simplify before you apply to the formula. Minus 3x, multiply the 3 here. Minus 3x plus 3h. And x okay, and this close here, close your parentheses for the first part. Now this becomes let me make space for you to see. Okay. We don't need the 2. We're going to multiply the 2. 2x squared. 2 times x squared. 2 times 2 is 4. 2 times 2 is 2x, right? 2. Then we multiply by the 2 by what? 8 term here. And we don't need the parentheses. Now, simplify this. See which one cancel. Right? Nothing cancel here, right? We're done with this. 2x squared, 4x, 2x squared. What f of x? F of x is the same. Nothing changed here. Control C, and here control what? V. Then f of x is the same. Let us go to this guy here. You see this guy here? I'm going to minimize it. Make it a little smaller. And give space, a little space here for me. Now I'm going to take a look at, I'm going to equal the limit, f prime, and we're looking for f prime, copy. Now, since we know all this, since we know f of x plus h, you see this guy, it's this guy. Then I'm going to take all this guy here and change this to be here, right? Okay, I'm gonna take this one to make a space for myself in the same. You know that. And okay, I'm gonna take f of x. Now I'm gonna put look here. I'm gonna take, because the negative sign, I'm going to add parentheses, and parentheses here, I'm going to put this guy here, instead of x. Okay, good job. You see, f of x plus h, leave it, right? This guy, all this guy from here. Okay. Good. Now what we need to do now, we need to simplify. We need what to simplify? Let me make space. Make this smaller. Okay. Now, you see this guy here? I want to simplify it. I'm going to take Control C. Okay. I'm going to remove this parentheses here. You see this one? Guys, when I remove the parentheses, all the sign will be changed. This negative, and this negative becomes what? Plus. I'm going to make this in red and this in red, just to show you that what I did. Okay, here, this -2 and negative. Most of the kids, they lose their what at this point. Okay, it's going to be 2x squared plus 4x. What you notice? Look at it. Look this guy. -2x squared and and 2x squared. They cancel each other, right? And we have here what? 4xh, and this guy, and this guy. They cancel each other. Wow! What left? I'm gonna take this copy. I'm gonna delete this. We don't need that because it's canceled already, right? And this one cancel, we don't need it. And this guy, we don't need it. You see that? You know why? Yes, and this guy, all these ones. I brought this guy. See the step before? Here, this cancel with this. This, we have only 1, 2, 3 terms, right? I'm gonna make equal here, and we don't need this guy. You will know why I left h in red. H. We have h as a greatest common factor, right, guys? Then, okay. What's happening? Okay, let me just try another way. No, okay, I'm gonna do it by myself. This will be equal limit which is this one. I'm going to take it step by step. Return space. Okay. Okay. I want to take the edge only. Parentheses. parentheses here, and keep the h as a common factor. You see the h here, we took h out. How much left here? Only 4x. I'm gonna take the 4x only. How much left here? Only 2h, we don't need that. The square, I'm gonna delete it later on. But we don't need what? This exponent. Okay, it's out. Plus 3. Plus 3. And here what we have? Only h. Okay. Now what happened h with h? This h and this h cancel. Right? They cancel. Then the last step is we're going to take this guy here, limit. I'm going to take only this as h equals 0, of which one? Only this guy in the parentheses. Control V. Now, at this point, I can replace h by the 0. Before, I cannot, because if I replace h by 0, that, you know what, make this undefined. Then this equal, last step, this equal only 4x plus 3, which is my derivative. Which is my derivative. Look here. Then my derivative is 4x plus 3. This is my derivative. Let me write it here. Then let me write back to my derivative sign. Whatever you want to use. Which one? You like this? Okay. I'm going to use this. Okay, then my derivative, Control V, equal 4x plus 3. This is my derivative. If I need, as example, if I need f prime of what you need, 2, 1. F prime of 1. You plug 1 where? In here. 4 times 1 is 4, plus 3 is 7. Let me go to the graph. Then the slope of the tangent line, look at, I'm going to read it. The slope of the tangent line at x equal 1 is 7. Just quickly to the graph, because I have 1 minute left for this problem. I'm going to delete this, and take this one. At 1 equal what? The slope of the tangent line? At x equal 1 here, right? Equal what? 7 here. You see this guy? 1 and 1. Plot 1 and 1. 1 and negative 1. 1, negative 1. Label. You see 1 and negative 1? If you graph the line here, right? If you graph a line, you will have it. What? I have just 10 seconds to say goodbye. And if you graph any line here, this line has a slope equal to 7. Guys, thank you and have a nice day.